Hello, everyone, and thank you for joining us for today's session. My name is Danny, and I'm the event planner for the New York Reactor Space. Before we start, I have a few things to go over. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary, remain professional, and on topic. Useful links will be shared in the chat. The session is recorded and will be available on demand 24 to 48 hours on the Microsoft Reactor YouTube channel. Which brings us to today's session. It'll run for approximately 1 hour with time for questions throughout. I will now turn it over to our speaker for introductions.
Hello and welcome. Welcome to the session on part 2 of the Azure Cosmos DB Developer Guide. I am Jasmine Greenaway, and I will be walking you through the guide today. So thank you so much for joining. I see the chat is really active. I hope you all are having fun building during this ongoing hackathon. If you are just learning about the hackathon for the first time, I will have a little link to show and share with you in at the end here, as well as I see also in the chat that some of you are looking for teammates. So I hope you found the right spot and place to find those teammates. So where we last left off on our application is that we built up the front end. We deployed that, and we actually played around with the Azure AI Azure Open API endpoints to and worked with essentially the proxy that some of you have tried out and have access to. I also have a link to that too, and tested it out on a Jupyter notebook with Python. So we tested it out just to explore that. And what we're going to do now is we're going to use that same service to create what we call embeddings, as well as apply a concept called retrieval augmented generation. So let's move on and talk a little bit more about what some of the modern things that an AI application needs today. So an AI application is most likely going to be some sort of web app. Maybe this is even mobile, or even even any kind of just application normal application that you would use every day, even down to desktop. And all these AI applications need particular things like you would in any normal application or a non-AI powered or non-AI generative powered application. So things like speed. Speed's always going to be important. But one additional thing is when you're working with AI applications, especially ones that require or rely on a lot of information, or maybe things like a customer base, you'll have maybe different types of data. And so you want to be able to work with these different types all under one application. Another thing, and the cloud's really great for this because you don't have to really, create the solution yourself. The solution's already in the cloud. You just deploy what you need and focus on the important parts of what you're building. Another thing is natural language interaction. So being able to have the user of your application be able to interact with whatever knowledge base that you may have. So instead of them, going to, for example, a database and writing queries, you want that query to actually be a question. So, for example, how many customers bought one particular product versus, select from where customer equals or product equals, whatever that product might be. And then also, whatever comes back, you want that to be accurate. You want that whatever the user to be looking for to have a good experience with not only getting, a fast response, but as well as a response that is meaningful to them. Another thing that a lot of applications face, whether non-AI powered or AI powered, is going to be scalability. And this is actually also important for AI, right? Because now when we're working with services like Azure OpenAI service or even OpenAI, you want to be able to handle the demand of the number of users that are coming to your application, that are handling they're handling the weight of your application. So another thing is like security and compliance are really important as well. And this can kind of come around the idea of responsible AI. And finally, cost effectiveness. You want to be able to manage this in terms of resources as well as monetary money costs. So let's talk about the application that we are building in this developer guide. So as we all know, this is a web application. So when we deployed this in about 2 weeks ago, we deployed the front end to a static single page application, also known as a SPA. And we deploy that to Azure App Service. And the App Service is an app service for really hosting any web application that you may have. So what we're going to work on today is the backend. So in the backend, we have what we call a container app, which is where we'll deploy the API. And this is where the API will actually interact with Azure OpenAI service and some other things that we are storing, including Azure Cosmos DB, as we see on the right, and as well as we can see Azure OpenAI on in the diagram as well. Another thing that you'll need here is container registry, but we already handled all of this in the deploy step of the guide. So we're going to go ahead and talk about one key feature within Azure OpenAI that we didn't explore in 2 weeks ago. So this is a concept of vectors and embeddings. So when we went through last week, 2 weeks ago, we talked about the completions API. So essentially, the interface that you might be very similar with is the chat interface, right? Like, for example, like ChatGPT, when you ask a question, it gives you a response, right? Or it creates some kind of textual content for you. Well, embeddings are a little different. And we'll be using embeddings to essentially create a product base for a searchable product base that'll be accessible through chat. So when we're talking about embeddings, we're essentially talking about this concept within machine learning. And it's a way to convert categorical variables or text into a form that can be input into a model. And so this can be, again, text, this can be images, this can be audio, video, anything that you can consider data is transformed to these embeddings, and what that turns into is these vectors. And this makes it super easy to search, and we store this output in what we call essentially a vector database or a vector store with an index. And so Azure Cosmos DB vCore actually stores these vectors for us in our application. So, in a traditional numerical representation, you might, for example, you might assign like a fruit to a number. So like 1 for apples and like 2 for bananas. And so, but this doesn't really capture relationships with the fruit. But in like a numerical representation, all the fruits are kind of equally different from each other. So for example, what we're thinking about, let's think another concept, like for example, camping. So when you think about camping, we're thinking hiking boots, we're thinking tents, maybe even cookware, right? Because you cook outside when you're camping, right? And so in the vector representation of those words would carry some kind of vector representation. So essentially a weight of numbers that when you search for those topics, you might see similar topics show up. So if I search for tents, I might see something like hiking boots show up, or even spikes for camping tents. So either way, this can be really important for things like products. In our particular example, when you're looking for one thing and you might want to find something that might be closely related. So maybe you're going on a camping trip and you need kind of a collection of things. So either way, That is what we're going to kind of take a look at today in terms of embeddings. Now, I gave you a very short example of, or short overview of what embeddings are like, but we're going to actually take a look at it in the notebooks in our lab. So we're going to move on to the existing notebook labs that we looked at today. But before we do, I just want you all to remember that you have access to Azure OpenAI through the hackathon through this particular proxy, aka the MS AI Hackathon API proxy. So if you go through that, you can log in through GitHub, and what you'll receive is a Azure OpenAI key as well as an endpoint, and you can use that in your application as you would in any Azure OpenAI tutorial that you might find. So with that, let's go ahead and move on to our first notebook. So I'm going to go ahead and come into here. And just to recap, we in lab 1, we played around with, in lab 0, we played around with Azure OpenAI. In the first and the second one, we played around a little bit more, and then we loaded our data into the MongoDB API. So kind of just, oops, let me just come back to our slide here, our notebook here. So we load our data and we added all into, we load our products, and then we kind of stopped there and kind of got part of our backend setup. So now the next step here is we are, let me just scroll up here. We are setting up our endpoint again. We're creating our clients, and we are connecting to Azure OpenAI through the client. And then we are creating, vectorizing and storing embeddings in each document. So essentially what we're doing is taking the data that we stored in Cosmos DB and creating vector representation of those particular products. And so here's an example of what kind of this embedding looks like. So this word, hello world, looks like this in Azure Open, or sorry, in a vectorized format. So and we use the embeddings deployment for that. So so the model that you're probably most likely familiar with when we're thinking about things like chat completion, so asking questions, creating content, maybe refining maybe an essay or maybe even a sentence, is the GPT model. So so for example, the GPT 3.5, GPT 4, things like that. But for us in this new concept of embeddings, we're actually using a different model. So so this one is called, let me just actually open up my proxy so we can take a look at it together in the browser. So let me open that up here. It is called text embedding ADA 002. So when I'm talking about chat completions, this is what I essentially mean. So we're working with GPT-5 Turbo to get questions or ask questions, and then we're using ADA, text embedded ADA, to create these vectors. So so for you, when you're deploying your application and you're working your application and you're using the proxy, remember, keep in mind that you can copy your API key, and then remember you can use these completion models for your application. Okay, so let's move on to our setup here. So in my example here, let me see if I can find my embeddings deployment name. So here, like I mentioned before, I'm using the proxy as well. So I just plop that embeddings deployment name in here, the completion deployments name here as well. And this is how I ended up getting this vector. And then the next step here is I vectorize and update all the documents in the Cosmos, the Cosmix Works Cosmic Works database. And so again, we apply that generate embeddings function here and go ahead and do that. I added a little bit more code here because I wanted to just keep track of my my collection. So, and of course, like this is when you clone it, you can do these same exact things as well. But then after that's all done, I go ahead and create my vector index. So this is, so there are different vendor indexes to apply, and in Python, this is essentially the command that you would use to do that. The type that we're using is called IVF, and there is another type called HNSW. But by default, we're going to go with IVF. And I know that my index is created because this is the output I get. So to do vector search in Azure Cosmos DB, we can actually leverage the Azure Cosmos DB SDK to do that. And what I'll do is I'll just kind of scroll down here and let you all run through it. But what we're doing here is we're searching for some particular products. So we asked, so the query we have here asks what bikes do you have? And here we go. So here are the bikes that are available to us. So keep in mind that it's not only looking for bikes, it's looking for road bikes and as well. And then we go a little deeper into our query here, and we ask, what do you have that is yellow? And it kind of this is kind of the idea of vector search, or using vectors for similarity, or as well as finding items that are similar. Notice that in here earlier, right, we saw that our bikes, we looked for bikes exactly, but with the context that we had from our previous question, when we asked, what do you have that is yellow? It gives me all these yellow bikes, but also it shows this frame here, right? Because a frame is part of a bike. So kind of thinking about, how similar the concept of a bike frame is similar to just an overall bike, right? And then in this next step, we do retrieval augmented generation. And this is this pattern where essentially you use your vector database or your vector store, as well as, or even just a regular data store like a database, and you use that with a completions model like GPT-3.5, and you essentially create a tailored answer around your data as well as the user query. So here we are asking, we're saying that you're a friendly sales assistant for Cosmic Works, which is a bike store. And its name is Cosmo. And again, we let our prompt says that, if our assistant does not is asked a question that's not a list, we respond with do not know. I do not know. And so here we're just setting up our method here to go ahead and ask the same exact question. So the difference here between what we did earlier is that we were directly working with the Azure Cosmos DB vector search feature, but now we are actually working with our completion model. We can see that here on this line right here, to really craft a user tailored answer. So because, right, we don't want to, like, for example, the user is not interested in things like similarity score, things like that, right? They just want to know what the product is. So so our assistant comes back and says, we have the following bikes, and stores them in just order, and just, or just not even just a particular order, just shows us the bikes. And then we ask the same questions, but we kind of tailor it a little bit more and ask what the names and the SKUs of our bike products are, our yellow products, right? And again, we see that our frames are the frame here, as well as our other yellow bikes is here as well. So this was a little test of just taking a look at vector search, as well as RAG, retrieval augmented generation. And then in this step, we also work with the LangChain API. But I'm going to actually take a look. We're going to actually take a look at this in the back end. So what I'm going to actually open up is lab as part of lab 5, and actually open this up in the browser. So this is the final step where we open we work with the backend API. So to run the backend locally, we go through these steps, and I have done that already here. But let me go ahead and open up this application and move it over here to my desktop or to my window here. And let's take a look what we have going on here. So just to give you a quick overview of the packages that we have installed here, the one that you see that's kind of taking up a lot of space here is LangChain. So LangChain is what we call a LLM orchestrator. And so essentially, when we're working with all these different AI packages and libraries, it's a lot to install, it's a lot to work with. So what LangChain allows you to do is to essentially import or install the LangChain package and be able to essentially what we call chaining, or have one step in your AI app process happen after another. So let's take a look at what that looks like. So let's go ahead and see. So here in our application, we are we're creating our deployment client, our completion client and our embeddings client. And we see that we have the same setup here. And let's kind of move on a little bit here. So here we are. So here kind of is our kind of the power of LangChain. So for example, this idea of a retriever that gets our data for us, and we can essentially use what's called a pipe here to format these documents into JSON. So thinking about some other ways that you could do this, you might have to install some additional packages to do that. But with a library like LangChain, and there's other libraries that do this too. For example, like Microsoft Semantic Kernel, that kind of have the same idea here. So just kind of moving on a little bit here, we're kind of doing the same things that we were doing in the notebook that we looked earlier, except we're kind of formatting them nicely for our API. So let's go ahead and run this. So the step here to do this, after you have gone into your environment file and updated it with your endpoint, your key, as well as made sure that the API, the completions deployment and then embeddings deployment, if you're using a proxy, is set up with the proper names, then you can go ahead and make sure that you install the requirements.txt file, set up your environment. For those of you who might be unaware on how to set up your Python environment, you can go to your, the command palette. I know the shorthand way, but let me see if I can find it here. Where is the command palette in the here we go. So it's Control-Shift-P on Windows, or you can just go to View Command Palette. But what you can do is you can go Python, create an environment, and then select the version. I'm just gonna. I don't want to delete and recreate mine, but I already have mine created. But it'll ask you what version of Python that you have installed, and you would select that. And this just makes it just kind of a proper way to essentially set up your development environment for Python. You also want to do that for your notebooks as well. Either way, once you have that set up and you install your packages, then you'll go ahead and you will run this particular, here we go. All right, this particular command here. And this is just a little package that serves up our application locally. So I'm going to run this and we'll see this running here. Gives us give us a second to, or give it a second to get started. And what this will do, it'll essentially use this application code and create our little backend test for us. So let me go and head to here. I'm just going to open it up. It looks like this initially, right? If you just go to this link, but if you go to /docs, and that also says it in the is it docs? Let me see. I think I might typed it wrong. It is localhost 8000 docs. So let me copy that in here, and I will paste that in. And what we see here is a fast API, and so what I've just done is accessed Swagger, and Swagger essentially is a way for us to see, kind of visualize our API and test it out without having to kind of use like a additional tooling to test out our API endpoints. So we have one endpoint here called AI. And so it requires a session ID and a prompt. And session ID is something that we can kind of make up for testing purposes. And if I try it out, I can come in here and create some test data in here. So what I'm going to do is I'm going to come into my steps here, and I'm just going to go ahead and copy this and paste that right into Swagger, and then execute that. And that should take a moment here. And while this is taking a moment, let's take a look at some questions here. What Python versions am I using? I think I'm using 3.10. Let me see. Let me check in my here. I'm using 3.12.3. But I have tried this on 3.9 and it worked fine. But I can see here in my endpoint was successful. It returned something here, and you can see that the price with product SKU, the SKU is this particular price. And if I look back into Swagger here, I can see that this is formatted nicely in here for us. Okay, so let's go ahead and look at some additional steps that we have in here to do. So after we do that, we walk through this process of deploying our backend API in a container. Now, the benefit of running, deploying a backend application or any kind of application into a container is that you don't have to worry about, the one thing that you have to worry about is the dev environment. You don't have to worry about essentially, and the other point there really is consistency. So you don't have to worry about it being consistent every time you deploy it. So so no matter where you run it, whether it be locally in the cloud, it should still have the same behavior. So in the API application or the code already has what we have called a Docker file. And Docker is how we essentially manage our containers. That's a whole other session within itself. But let's go ahead and take a look at what this Docker file is doing. So we have some basic things here, things that we already did, right? We installed the requirements.txt, and then it serves this this API package for us, the UVI corn that we ran in locally on our machine. So after that, we go through a couple other Docker steps here, and you can just kind of walk through that. And if I do that, let me just go ahead and see if I can help run this for me. And let me go ahead back into, let me stop my application here because I remember I was running it locally. And then I'll go ahead and paste it right, my command right in here. Okay, let's go ahead and saying backend APIs you are using by container. You have to remove or rename that container to be able to, actually, maybe I already have it running. So let's see. I actually already do have it running in here. I actually already did have it running in here. Let me just make sure and see if it works still. It does. Okay, great. So I can run that same test that I did before, and I'll just kind of copy the body here of my previous command. And let's go ahead and try it out. Paste it in here. And what was the price of product was SKU this. Let's see. Let's go ahead and do a little bit more experiments. What was the price and color of the product SKU here? And let's go ahead and execute that. Run it one more time. And I am just copying, and we can see that it also shares the color. And so we can also do some more here. So I could say, what was the price of the color product SKU? And let's see, and find similar products in this price range within, I don't know, let's say 300. Within 300. Let's see what we get. Gave us a little bit of an error here, but that's okay. So, but let's just also go back and just make sure that our initial prompt worked here. Okay, yeah, that's still fine. Okay, great. So after that, then we would go ahead and move on to deploying it to Azure Container App. So now we're going to essentially deploy it to the cloud. And you would kind of go through steps and do kind of the same similar steps that you did locally, and just essentially deploy it to the cloud. You would log into Azure, the Azure command line. So now you can, by the way, you can do this in the Azure portal. So let me just kind of show you what that looks like. So I'm here in my Azure, my Azure portal, but I can open up the Azure Cloud Shell here. And what's great about that is that I don't have to install the Azure CLI. My mouse is a little funny here, but let me just close and open that again. I mean, I can do all those commands from the guide in here. Another thing is that for these particular sets of steps, you'll be spending a lot of time in the Azure or in the Cloud Shell. or in the command line. So I would actually recommend that you would go to something like the Cloud Shell. So Cloud Shell, I believe it's cloudshell.azure.com. So let me see. I believe it's cloudshell.azure.com, and then you can just have a full window here of the Cloud Shell. So, and then you can of course have like the portal in another tab if you need to look at stuff and copy stuff over. Okay, so once you do that and you go through all these steps to install or to set up your container app, keep in mind that there is one additional thing you have to do here. So when you set up your container, you have to delete this hello world container. And the way you do that is you just come into your container app and you go to this containers setting here. So let's walk through that together. So I come in here in my container app. I have mine already pinned here. I come into containers. I already have mine deleted, but I would hit edit and deploy. And when you run those commands in the Cloud Shell, you will see this, or whatever the name of your container is, your container image is, and then you'll see another one called Hello World. So you would just like select that and click delete, and then click create. You would refresh the page, and then you should not see that Hello World thing or the Hello World image in there anymore. And then you can move on to the next step, which is pretty much it's time to run your backend. And so we can do the same exact thing that we did before. And you can see that I did that in here. I also just refresh it here. And I'll apply the same test that I had before. Let's copy. And you can see that my container app is different now. Or I'm in the container app now. I can try it out. Paste that in here, and we can execute that. And we should see the same exact behavior. Perfect. Great. So at that point, we have our backup set up, and we can work with our front-end application that we set up in our last 2 weeks ago, or 2 weeks prior. We walked through deploying our application through Bicep. So what we'll see is something like this. So unfortunately, my application, for some reason, I think I might have deployed something incorrectly. I'm running into some issues here. Let me, for those of you who might have walked through the guide and ran through this, let me know if everything worked for you, or if you had to do any troubleshooting on your end. And if you actually did, and you have some suggestions, I would recommend that you would actually make a PR to the developer guide. Sometimes things break, and that's just a fact of life, as we all know. So what I have for you here is an additional demo that I can show you. And let me just get this set up in my other browser window. And unfortunately, this is not really applying the concept of RAG, but it is the same exact setup here. So I'm just going to go ahead and fix this up for you, and then we can try it to get, and you can take a look at what I have here. So let me just fix this up, and then we will move on. Okay, so I have an application here that I was testing out. This is a local application, kind of the same chat setup here that we see in Azure Casualty or in our developer guide application. But the only difference here really is just really the UI. This is deployed to a this one is running locally, but I could deploy it to a web app. I could deploy it, and I can deploy it to separate. I can deploy it separately, the backend separately to a container app or whatever service that supports backend applications in Azure, and of course deploy the front end to something like Azure Web Apps. And I just had a little test here where I was checking the highest points in Florida in descending order. For those of you who have never been to Florida, it's pretty flat. But what I'll go ahead and here and just say like, where are the best places to hike in Florida? And let's see what we get. And let's see if this, okay. And here we can see that we get a couple of suggestions here. So just this, the main thing here is that the chat interface is different, but it kind of works the same. We send our query, we send our user input to our LLM. In this particular example, it sends it to our chat completions, model. So GPT-3.5. In this example here, we also interact with GPT-3.5, but we also interact with our visual, or excuse me, our Cosmos DB vCore from MongoDB vCore vector store database. But another step here that we also do here is we actually notice that in our application or in the code, we also use the embeddings model, that ADA 002 model, right? And so what we're doing here is we actually take the user input and turn that into a vector. So those numbers, that set of numbers, and we use that to compare it and also search in the database for a question. So what we get back is an answer from our LLM, from our GPT-3.5 model, as well as what is returned from the database. So unfortunately, I'm sorry I couldn't show what happened here, or what should happen here. Looks like we're running into an issue, but we can follow up in the Discord that I hope all of you have joined in. But let's go ahead and wrap up here. So let's go to our last couple of slides here. Let me advance this. Okay. So if any of you are looking to go through the developer guide yourself, go ahead and check out the short links. They should also be in the chat. If you are a Node.js developer, if you prefer JavaScript, there is a Node version for you as well. And I know I've been talking a lot about this hackathon that's ongoing right now. Remember that this is an opportunity for you to show your AI skills, as well as use Azure OpenAI, because remember that you have access through that proxy. So you essentially get to learn all about how to build AI applications through the guide and through the Cloud Skills Challenge that is going on right now for Azure Cosmos DB. You can learn more about it at the short link here. But you can kind of learn how to build these apps for yourself, as well as compete with others across the globe for prizes, and just feel really proud of yourself about creating an application. So thank you all so much for joining again. I hope to interact with some of you in Discord, and I hope. Also, I forgot one point here. I believe in about 2 weeks, I will be here. I will be in the Discord, interacting and answering questions in Discord for office hours. So be sure that you check that out and come say hi. And that is about it. Does anybody have any final questions before we sign off for the day? Oh, Nicholas, I see you have a question here. The container that I had initially when I was running it locally, I was using Docker Desktop, and that's really simple, easy install. So you just go to the Docker website, install it, and give it a moment. You might have to restart your machine, at least on Windows. Give it a moment, let it warm up, let it get started, and then you can essentially run those same commands locally on your machine. And then you should be able to just use container apps, Azure Container Apps, to do the same exact thing that we do locally. Okay, well, I see there are no questions. Remember that you could also always go to the forum in the DevPost Discord to ask any questions. It's really cool to see you all helping each other out, answering questions, and supporting each other. Okay. Oh, I see a question here. So what's the difference between vector embedding versus interacting with completion models? What's our advantage? So great question. So the difference is that, completion models are more for text generation. This is for, I am sure some of you all have seen some prompts from maybe recruiters or anybody like that says, create a resume for me that highlights these particular skills. So that's what you use a completion model for, to create content to generate text. Vector embedding is specifically for creating similarity between data. So, for example, whether it be text or images. So it's more of a vector embedding is more of the process of creating similarity, between texts and other types of data. And normally that's used in conjunction with a vector database, because that's information that you normally want to be saved. And in the concept that we saw in their chat application, we actually also take that user input, turn that into a vector so that we can compare that against the database. So that's kind of really the example here. One is for text and one is for vectors to help us search better and easier. The hackathon link, I saw in folks, some of you were asking that for the link for Discord, and that is in the hackathon short link. So be sure to sign up and check it out. There's still time. There's still a lot of time here. I also see a follow-up question. Vector is for sort of searching using similarity. Yes, exactly. Any other questions before we sign off? All right. Well, thank you all so much for your time. Thank you for being patient with the late start. And I will see you at office hours and on Discord. Thank you so much for joining. Happy building.